So let me first just thank you all for coming out here. Thanks for attending reInvent. Pretty meaty session, as I mentioned before we got started. Now, if you're like me, and a lot of customers are, first time you went out and you created your AWS account, you're kind of like the lone developer working on a single project, probably didn't care too much about how you manage that account because you were a team of one. Over time, the team grows, you start adding people, and you start to think, okay, should I really be sharing that same username and password with root credentials with everyone in your team? So if you're in that boat, or you've gotten to that stage in your use of AWS, then you're in the right place. Because for the next 50 minutes, we're going to talk about how you delegate access to your AWS environment. My name is Jeff Weir, and I'm a product manager on the Identity and Access Management team. I'll probably refer to that as IAM through the session. So I want to go through some of the goals for this talk. Really, the two things I want to get through this. So first is an understanding of the technology used to delegate access. Specifically, we're going to be talking about the security token service. I'm going to be calling that STS for the next 49 minutes, and how you use roles to delegate access. There's two types of sessions that we're going to hone in on during this presentation. Those are sessions that are role-based sessions, and then there's also federated sessions. There's some differences between them, pros and cons, and towards the end, I'm going to show you a couple different scenarios on how you use them, and towards the end, I'll give you some strategies on when to choose which type of session for your application. Throughout the presentation, I'm going to be using some use cases, some demo scenarios to showcase this. We're going to be looking at cross-account API access. This is something that we just announced last week. And we're also going to go look at a couple federation examples, doing API federation as well as single sign-on to the management console. Since this is a pretty detailed talk, I thought I'd just start off with a demonstration. Actually, this is still in the slides here. So the first one that I want to go through is how you do single sign-on to the AWS Management Console. And before the demo, I'll walk through a very brief diagram just kind of showing the process. Once again, I'll try to put URLs in the presentation. So for those of you who are interested in the code, you can go to that URL and you can download it. In this scenario here, we're going to be looking at a customer who's using desktops that are joined to an Active Directory domain. So the user's going to sign into their workstation. They're going to be authenticated by Active Directory. And then they're going to hit an internal proxy server or a broker. All right? When you hit that broker, you're going to go in and you're going to be able to select the role that you want to play inside of AWS. And by selecting that role and clicking Sign In, you're going to be automatically logged into the AWS console without having to use your AWS username and password, without having to create an IAM user or anything like that. So let me show you how that works. So one of the things we just, if any of you subscribe to the AWS blog, we just actually announced this morning. So once again, this is kind of the sample code that I'm going to be going through for this part of the demo. And you can go here and you can download it. Mouse is a little crazy. In there, one of the things that we actually provide is, of course, the documentation and the source. But for those of you who just want to play with it, we also created an MSI. So you can double click that. It walks you through a wizard, except the EULA. And then you put in some configuration. And what this is going to do is it's going to deploy an IIS site, an Internet Information Server site on a Windows server. I should probably describe the environment a little bit. As any good chef would do, I've already had this cooking in the oven, so I've already got this deployed. My environment here is actually a Windows server. I've created my own domain, and I've logged into that domain as a user. So what I can do is open up another tab here, and I'm just going to hit that proxy server. So I get signed into the AWS Management Console, and from this drop-down, I have two options. I can log in as an admin, or I can log in as an S3 user. So the question is, how did those get there? How did I magically create those? So I'm going to bring up the Active Directory Administration Center. This is just one of those standard tools you get with Windows Server. And then there I've created a user for myself. So there I am, Jeff. And if you look at that user, I'm a member of a number of groups. A couple built-in groups like domain admins and domain users, and then there's a couple groups that I created, AWS admins and AWS S3 users. Now what that proxy server is actually doing is it's looking at my user group membership. It's creating a list of all the groups I'm a member of, and then it's also going over to my account. Sorry. And it's looking at the roles. And so here in my AWS account, I have an AWS S3 users and I have an AWS admins role. And it's doing the intersection of the group members that I have in Active Directory along with the roles that I have in my AWS account, and that's what's populating that list. And so now when I go here, I can just select the role that I want, click sign in, and I'm in. I'm in my account. The only difference you'll see up here is instead of logging in as my root or as an IAM user, it's actually showing that I'm assuming a role. That's all you need to do to be able to log into the management console.
So you don't have to provision users on the console side and log in their role account?
So the question is, and I should probably mention, I'll probably hold questions to the end just because I'm going to need every minute, but this is an easy one to answer. The question is, do I need to create any users inside of IAM? And the answer is no. So this is all managed inside of Active Directory for this sample. So I know I went through that pretty quickly, and so some of you may be saying, okay, wait a minute, what did Jeff just do? I'll review that. I logged into my Windows desktop, okay? I hit an internet website. I chose the role I wanted to play in AWS, and then I was automatically signed into the console. So how did I do that? That's going to be the focus of the remaining part of my presentation. And before I get into the bits and bytes of how that works, I want to start at some of the basics. So in order to do this, you need to understand how delegation works, this concept of a session that we have in AWS, and the security token service. So sessions 101. This is basically how you delegate temporary access to your AWS account. All right? These are generated by calling and requesting a session against STS. When you call STS, you're going to get a set of temporary credentials, and you're going to use those temporary credentials to make subsequent calls to all the AWS APIs. So you could think of STS as kind of a ticketing or a vending service. All right? You make a call to it, and it goes ahead and it creates a session. And a session's got a couple of different parts. So first are the temporary security credentials. This is your access key ID, your secret access key, and your session token. So the keys are very similar to the long-term credentials that you're using. If you're using root or you're using IAM credentials, you're already familiar with the concept of keys and how you sign those API requests. The only thing we're really introducing that's different when you're using temporary credentials is the token. And the token is what allows us to verify that those keys that we've granted you are still valid. You can use it in a couple ways. So if you're using it against S3, you use it in the HTTP header. Let's say you're making other API calls and using the SDKs, you're just going to set the token parameter on that. There's 3 different ways that you can get sessions today. Okay? 3 different APIs and 3 different session types. There's get session token, and that'll grant you what we call a self session. You can use get federated token, that will give you a federated session. Then we completely change the API on you, and we created assumeRole, and that will create an assumed role session. For the sake of this presentation, we're going to focus on the last 2. Self sessions are just that. They're for yourself, so you're really not going to be using them to delegate access. But the last 2, we can go to build applications that allow delegated access to your account. Now, there are expiration on these. These are temporary credentials, and the expiration does vary on the type. So if you look at the self session, if you're using your root or your account credentials, you're gonna have different times in terms of the minimum that you can have, the maximum, and the default. So I won't spend too much time on self. I just put it on this slide just for clarity so that if you're going through, you're wondering around expiration, how do they vary. Now for Federated and assumeRole, both of them have a minimum of 15 minutes. By default, Federated sessions last 12 hours. When you go and you request it, you can request up to 36 hours. Roles, on the other hand, by default are 60 minutes and have a maximum of 60 minutes. So if you try to go and specify a time measured in seconds greater than 3,600, you're actually going to get an error telling you that you can't have a session that is that long. One more thing I want to cover on that. Yeah, the last bullet is pretty important. Please use caching with these credentials. So it's good for you, and it's good for us as well. You want your applications to perform. So if you create a federated session and you have a 36-hour expiration on it, there's no need to go and call for another session every time you make an API call. If you do that, you're likely to get an email from me. If you keep doing it, you're likely to get a phone call from me. So please, cache your credentials. It'll make your applications run faster. So how do we do role-based delegation using the assumeRole session? So hopefully some of you saw the announcements around IAM last week. We also announced roles for EC2 over the summer. And some of you were able to make Jim Sharf's session, which was right before, the hour before this one. For those of you who haven't, though, let me give you a brief 101 on what a role is. You can think of a role as an entity or a container for policy. Despite the name, don't confuse it with like role-based access control, okay? It's not associated with a specific user. It's not like a group. You don't add users to it. You assume the roles. So for example, let's pretend during the day I'm a mild-mannered product manager at AWS, and at night I assume the role of a superhero. And so when I assume that role, I get additional attributes and different privileges. Maybe I have super strength, maybe I have X-ray vision, whatever you want. Imagine me in a cape, doesn't matter. That's what I get when I assume the role. There's one caveat when you're working with roles. You can't assume them with root credentials. So you want to go and either create an IAM user, or another way to use roles are if you already have a temporary session from a role, you can use the credentials from that role to then assume another role. But you don't want to use root. You'll actually get an access denied or some type of error. I forget what the exact wording is on that. So using roles with EC2. This is where we first introduced roles over the summer. And what roles for EC2 allow you to do is take those applications, and if you're using AWS, you have built an application in EC2. And inevitably, when you built that application had to access other AWS APIs. So you go and you launch an instance, and that instance needs to read data from a DynamoDB table, or it needs to pull a file from S3. You're going to need credentials on that instance. So prior to roles, what a lot of our customers did, they would go create an IAM user, take those long-term credentials, embed them on the instance. Our best security practices say you should be rotating those credentials, right? Everybody rotates those credentials, yes? But we found out that a lot of people weren't rotating those credentials. So we added roles for EC2. And so this really simplifies the entire process. You go in, you create a role, you attach a policy to that role, and you launch an instance with that role. Behind the scenes, we take care of all the complexity and all the muck. We get the credentials out to those instances. We actually rotate those credentials multiple times a day. And if you're using the AWS SDK, you simply need to build your application, and the SDK will actually pull the credentials from the metadata cache, and there's nothing you need to do. Nothing you need to do. So let me show you how you actually create a role and launch an instance. So in my account, I can go in, and this is just, I moved to the IAM tab. I may do things a little bit quickly, so I apologize. And there you switch over to the roles, and I can go and I can create a new role. And so in here, try that again, create a role. In here, I'll put in my reInvent demo. Click continue. And this is what you're here doing is I'm creating a trust, and I'll show you what the other options are, but for now I'm going to show you how you can create a role with a service, and it's real easy because right now the only service that supports it is EC2. And then I'll play a little bit of policy template roulette. Take Elastic MapReduce. Produces a pretty good policy. And by doing this role, the only thing you're going to be able to do is have MapReduce read-only access. So I'm going to go ahead and create that. And I'm going to switch over to the EC2 tab. I'm going to launch an instance. Select the good old Amazon Linux, AMI. Maximize. And then this is what I want to show you. Down here, you can go and you can just select and apply the role. And that's all you need to do to launch an instance with the role. Okay? I won't go through the whole process of deploying it. But now that I've done that, every application that you run inside of that instance will inherit credentials that will allow you to do MapReduce read-only access. And that's it. No more key rotation, nothing that you need to do on your side. So let's review some of the benefits of roles. Obviously, this eliminates the use of long-term credentials. And I probably should put a star on there, because there's a couple instances where I'll get to the end where you may still have to actually use long-term credentials. But in the future, this will completely eliminate the use of long-term credentials. Also, if you're using this, you don't have to do the manual key rotation. I know a lot of our customers who went out there and they built the code and they actually have their own homegrown ways of this. This removes all of that. And less coding. If you're using the AWS SDKs, the APIs will pick up those keys automatically, and there's nothing that you need to do. So more recently, and more recently being just this past week, we introduced cross-account API access. And this allows access across AWS accounts. So myself included and a lot of our customers have more than one account. And we know customers who have like 10s and 20s of account. And so you may want to build out manageability scripts that allow you to see all the resources across those accounts, all your buckets, all your EC2 instances, all your databases. And cross-account API access allows you to do that. Also, it may be that, hey, you've put a bunch of, you put terabytes of data in an S3 bucket. You don't want to move it, but you have an application running in an EC2 instance that's in a different account. And so how can you get that instance to be able to read data from a bucket that's not an account maybe that you own? Cross-account API access will allow you to do that. Last but not least, this is an alternative way for you to use third-party management tools. So I know a lot of you use some of the partner offerings that our partners have out there to manage your accounts. Today, you're probably generating long-term credentials using IAM and handing them over to them. In the future, you'll be able to create a role, point a role to it. They simply assume that role. If at some point in time you no longer want to use their service, you delete that role, you've effectively revoked the relationship with them. The way that this works is really kind of an extension for what we had for roles for EC2, what I showed you in the previous slide. Same kind of flow works. You go and you create a role, you apply a policy to it, and then you specify that trust. Now, in the previous example, the trust was specific to EC2. If you look over to the screenshot on, I guess it's my right, I don't know, it's always your left or whatever. You can see that you can actually specify a service, which we looked at, or you can specify for cross-account access. Now, that needs to go to what we call a trusted entity. That entity can be an IAM user within an account that you own. It can also be an IAM user, an account that you do not own. And then once you've established the policy and you've established the trust on that role, the last thing you need to do is you need to give a policy for that trusted entity. And I'll show you a diagram that makes a little more sense. But the policy that you want, basically, there's an example one in the lower corner that shows that you're granting that IAM user the ability to assume that role. And so this is how it works, and this is a real-life example. So I have my AWS account, and I also work on the IAM team where we have a team account. And in my account, I have a user. His name is Jeff. And I want to get to objects that are in an S3 bucket in the team account. So this is what I have to do. Over in the team account, I create a role. I'll call it my S3 role. And in there, I'm just going to grant full access to all the S3 resources and APIs. And the next thing I need to do is establish that trust. And in that trust, what I'm doing is I'm setting it up so that I'm pointing to the Amazon resource name, or the ARN, for my account. So you can see it's maybe a little bit little on the screen there. The account ID in there matches the account ID in my role. So this is only half of the relationship. The other part you need to do is in my account, for the IAM user, I also need to create a policy that allows them to assume it. So there's three pieces here. In the trusting account, I need to have a role. That role needs to have a policy, and that's what you're going to get. Those are your privileges when you assume the role. And it also has a trust saying this is who can assume it. And then in the foreign account, in the trusted account, you have to create an entity, and that entity has to have a policy that also allows it. So this is the kind of two-part configuration you need to do to establish this trust. What ends up happening is Jeff uses his long-term keys, his IAM keys. He makes a request to STS. He assumes that role. STS returns to him an assumed role session that has a temporary set of credentials along with keys. And then I use those keys to make subsequent sign requests so that I can access that bucket. So let me show you how that works. So this is another sample application that I created. This one I don't have up on the internet, but I'll probably clean it up at some point and put it there for you to play with. And there's a quick setting. So in my account, I have an access key and a secret key. These are Jeff's credentials. And then this is a role in the other account. And so if I were actually to go into S3, I'll show you this just from the management console. Nope, that's the wrong one. Let's just go down here. So this is the team account. And in here we have a set of buckets. For example, there's a bucket for me, and this is all in our shared account. Now, what I want to be able to do is be able to see my shared account along with my private account. And so I'm only going to use one set of credentials and a role in that account. And I'm going to go over here, and now I'm browsing a whole set of different buckets, which are my private buckets in my private account. So for example, here I can go in and pull up a picture of my kid. Hi, Daddy loves you. And then at the same time, I can go over into my team account. Now, you could do this today, but if you did, you'd have to have a set of long-term credentials for every account that you want to access. And so I'm doing this with one account, and I can specify n number of roles and access all the resources across all those accounts that I've been granted access to. So for example, I can go down and I can browse to the same bucket. There's a README file. Hello, everybody at re:Event. Clap if you read this. Thank you for humoring me. And that's cross-account access. Okay, so we've simplified that process. So let me review a couple things. Oh, actually, I wanted to go through this. I did promise some code. So it was a little bit hard to see in the debugger, so I created some slides around this. The sample itself is pretty big, but this is a self-contained function which you can use to call an assumeRole. So what's actually happening in there is the Jeff IAM user is using his access key and his secret key. And then the stuff highlighted in yellow is where we're making that assumeRole request. It's a pretty simple request. I'm just specifying the duration, maximum of an hour. I'm specifying the ARN for that role. And then I'm giving it a name. In this case, the name really doesn't matter. And then when I make that request and I get the response back, it'll have a credentials object part of that, and I return back those credentials. And in there will be an access key, secret key, the token, and the expiration. Everything you need then to make calls to that foreign account to be able to access things like an S3 bucket. So what did we learn? So use one set of credentials, okay? No more sharing of long-term credentials with your friends. So you have an account, someone needs access to it, create a role. Maybe you can create a very specific role. You can only get to this prefix, prefix in an S3 bucket. And at any point in time, you can revoke that access by deleting that role or modifying that role. So let's get back to Federation. This is kind of where I started. And what I really want to do is kind of give you first kind of an introduction. So what we're doing with Federation is we're allowing you to access your AWS account using your existing identity. For example, your corporate identity, right? Why would you want to do this? Well, I think the obvious one is you can build applications that transparently access AWS resources. So let's say that every employee in your company, when they log into their PC, you want them to automatically back up their documents folder to some prefix, some folder in S3. You can write a little application, runs in the background. They're authenticated by Windows Active Directory. And in the background, you just go and you start that copy, and they don't have to do anything. So that's one benefit. The other thing we're going to take a look at, we looked at it earlier in the presentation, is if you have system administrators and you want them to be able to single sign on into the management console. The nice thing about this is it eliminates yet another password. Yet another password that your users have to remember, and yet another password that you have to manage. So it eliminates that, and it keeps it all within your corporate directory, all within your corporate governance. So let's go through the first sample. Once again, the URL is up there for this one. I modified it slightly, but most of the code is pretty much the same. In this case, we're going to have the identity provider is actually going to be Windows Active Directory. It's because I'm running everything from a Windows EC2 instance. The privileges are going to be based on AD group membership. But one level higher, I'm actually going to start storing policies on unused AD attributes. So this is how I'm actually going to give the privileges to those users. The relying party in this case is going to be S3 because it's easy to demonstrate. And we're going to be using a federated session using the get session token API. The way this works is a user logs into their application. In this case, it's just going to be a simple command line application, and it hits the proxy server. Now, the proxy server needs a set of long-term credentials to request the session. Now, the way that federated sessions work is when you request the session, it inherits or it derives the permissions from the IAM user. So let's say that you have users who need to access EC2, you have users who need to access Dynamo, you have users who need to access S3. That IAM user is going to have the unified privileges of all of those. And if, say, you have users who need admin access, then that proxy account is going to need admin access. So this can become a pretty privileged account, and so you definitely want to secure those credentials on that proxy server. Anyway, they hit the proxy server. It gets authenticated by Active Directory. We're going to determine their entitlements based on their group membership and policies that are applied to those groups. And then we're going to make a call over to STS requesting the session. It's going to give us back the session response that includes the temporary credentials. The application is then going to take those credentials and make subsequent calls to Amazon APIs. So there's a proxy server involved in this demonstration. And that proxy server is actually a Windows Communication, in this case, is a Windows Communication Foundation or a WCF application. Let me just remember where I put it. So that is here, and I'll just step you through, nice. I'll step you through some of the code that's relevant to this. So the first thing is I'm using NT authentication. That's why you're not going to get prompted for username and password because you're already authenticated. By the way, this is written in C# for all the Java folks. Hopefully you're able to follow along. In here, I'm going to use a helper object, a helper class, which takes the username and creates the token. That's over actually in this class where I'm going to make a get federated token request. It's similar to the assumeRole one in that I need to specify a duration and a name for it. But in this case, I'm also going to specify a policy. And once again, I use a helper function over here to generate that policy. And what that policy does, it's actually a bunch of Windows Active Directory code that goes and looks up the group and then checks the policy on that. So rather than walk you through that, I'll show you how I set that up. So once again, this is me in Active Directory. I'm a member of this S3 users group. If I open up the group on there, I can go down and view the attributes for it. And conveniently, there's an unused alt security identities attribute where I've specified a snippet of IAM policy. I call it a snippet because it's not a complete policy. It's hard to see there, so I put it into Notepad so that you can see it in full screen. Basically, what this is going to do is it's going to generate a policy on the fly. It's going to swap out some variables such as username and bucket name. And when I make that federation request, I'm going to attach that policy to the request. And so these will be it'll be the effective permissions of whatever the IAM user has, further restricted by the policy that I'm submitting. So if I switch back over to Visual Studio, I have this sample console app. I'm going to go ahead and start it. This is where it's making a request to the service. It's going to get those credentials. And then I'm going to be able to see all the items that are in that same bucket that we looked at when I was using the S3 Explorer that I created. Once again, I can put in, just to kind of show that this works, I'll put in the same text file. And so everybody should be able to see that. Go ahead, clap if you read it. Thanks for playing along. And I hit enter. So that's all you need to do to actually do the API federation. So just to kind of review what you saw. Oh, and I think I have code for this one, yeah, as well. So it's very similar to the assumeRole one. The main difference there, of course, is that I'm attaching the policy. Now, you can do that when you make an assumeRole request, you can also attach a policy. But here it's kind of mandatory because you want to be scoping down those permissions. But once you make that request and you get the response back, it's the same thing. There's a set of credentials, and you can take that object, and you can use your access key, secret key, and sign subsequent requests. So that was using a federated session using the get federated token API. You can also use roles for federation, all right? This provides a different option for storing the AWS permissions. This is a subtle difference at the first time that you play with this, so I'll kind of try to stress this over a few times. In the previous demonstration, all of the permissions were managed in AD. It was based on AD groups, and on that group there were attributes that had policies. Well, what if you have a set of AD administrators who manage those intranet resources, but you have a set of different individuals who manage AWS? Roles provides that opportunity to separate powers or separate duties. And so the AD administrator, they go in and they create the users and the groups and they manage their intranet permissions. And then the AWS administrator goes in and creates a role. And they specify the policy on the role. And so they're in control of the permissions that are going to be used when you assume that role. So we're going to go through another case. Once again, URL. Someone wants to take a photo. That's at the bottom there. The identity provider is going to be Active Directory again. I'm also going to use group membership, but instead of the policies being based on attributes on the group, I'm going to assume roles of the same name in my IAM account. And that's how we're going to get the policy. And in this case, instead of using API Federation, we're going to single sign into the management console. So this is actually how we built the first demonstration that we looked at the beginning of the session. And once again, this is using an assumeRole, and we're calling the assumeRole API. So when we looked at cross-account access, that was how you had to configure it when you were working across two accounts, two distinct accounts. When we're doing federation, it's actually using roles within your account, so it's a little bit different. So in this case, I have a proxy server, and that has, it's an IAM user, and it has a set of long-term credentials. And that user is going to assume roles within the same account. So in this case, I show we have an admin role, and we also have an S3 role. So we'll take a look at the S3 role. There, once again, the policy looks very similar. I'm going to grant you can call any S3 API on any resource when you assume this role. The trust is a little bit different. So in this case, the trust is pointing to the ARN of an account. That account is actually the same account where it's created. So just because I'm creating a role in my own account, I still have to specify that I'm trusting my account to assume that role. That's still a necessary step. The other thing that I'm using in here is a condition. And for that condition, I'm setting an external ID. And in this case, I'm setting the external ID to the SID of the group, the security identifier for the group. So when you create a group in Active Directory, you get a unique GUID, a unique ID. And if you delete that group, it will generate a new ID. So if anyone over in Active Directory is deleting groups or making modifications, that GUID will change. If someone tries to then assume this role, that will break the trust. This is another way, an additional layer of security that you can use when you're building those roles. Likewise, that IAM user also needs permissions to call the role. So even though we're doing this all within the same account, you have to go through the same process. Now the one thing I'll point out here is in the previous example, we were just granting them access to call assumeRole. Here I'm actually granting them also the ability to call listRole. And these are the only two privileges that IAM user has. So you don't have to worry about the union or having the union of all the privileges of all the users. These are the only two privileges you need to assign for this IAM user in this scenario. So this is just what's happening in the proxy. We do the key dance, and then of course I'm going to use those keys to log into the management console. Now that's just one part of it. The whole kind of loop looks like this. User opens up his web browser. They hit that proxy server. As I mentioned before, the proxy server is going to use a set of IAM credentials to eventually call assumeRole. What happens is we authenticate you against Active Directory, and then I'm just going to enumerate the groups. I'm not going to pull policies off the groups in this example here. Okay? Then I'm going to list the role. I'm going to make my first call to STS, which lists the roles. That's going to return back a list of all those roles, and I'm going to do a union based on name matching to populate that drop-down box in the proxy server. User selects the role they want to play. We call assumeRole, and we get back the temporary credentials. There's actually a step in here where we generate the URL by calling a sign-in token, but I ran out of space on the slide. And then we redirect the users into the console. So let me show you how that worked. You guys already saw the final product, so what I'll do is I'll show you what's actually happening behind the scenes. So I'm going to go ahead and run this, and it's already authenticated the user, and it's already done the list roles. Now what happens when I try to assume the role is the first thing it goes through is it's going to try to get those temporary credentials. Okay, so I'll step into that, and this is where we assume the role. So like the previous examples, I need to set a duration. This happens to be 3600. I need to specify the ARN. In this case, I chose the admin role. And then the username, I'm going to specify myself at the domain that I'm logged into. So I generated that string. And then this is where I specify the GUID. once again, if the GUIDs don't match, like the domain administrator has to give the GUID to the AWS manager, the AWS admin, and if those GUIDs don't match for any reason, this is how you can break the trust. This is how it'll be invalidated. What actually happens at this point is we take the keys. I'm not going to show you my secret key, but I'll show you my access key. And then there's the token. And I take those 3 pieces of information, and I start to, what I need to do is generate a sign-in token. And so this is where the sample becomes pretty handy, because I think if you go on in our documentation, we have like 1 sample for Java, 1 sample for Ruby, and now we have a sample for C#. So you'll want to follow along, because this is probably one of the more mystical parts of how you create the sign-in URL. But that does a dance where it gets a sign-in token, and then at the very end, we get a well-formed URL, a very nice and lovely URL. And so I can spit that out. Geez, gotta scroll. I'm just gonna copy that for a second, and I'm gonna show you that this is not specific to anything. If I want to, I can launch a new browser. I can drop that URL in. I could email it to you if I really wanted to, and that will log me into the console, and since I'm the admin, I have full privileges to everything that's happening in there. And of course, if I let the application run, that's gonna open up in Chrome, and you get the same result. So once again, we've provided that sample for you. You guys can go and download it. You can play with it. You can also modify it for your own needs. Because creating that sign-in URL is a little bit tough, I won't go through the code sample here, but for completeness, the slides are available after the session, so you can copy that. That is a completely working function. In the code sample that you download, we've actually broken up a little bit. It's a little bit better looking code, but if you want to test it, this definitely works. Want to go back and just kind of go back and talk about some of the benefits and some of the things that we saw. And then I want to, in the final 10 minutes or so, I want to talk about some of the differences between the federated session, using roles, and some of the pros and cons. But to wrap up here with federation, obviously the benefit is you get to leverage your existing corporate identity, right? You get to use the username and password that you already know and love. The nice thing about it, too, is you get to enforce that governance. So maybe inside your company, you say that, hey, you got to have 3 special characters, 3 digits, uppercase, and you got to rotate your password every 30 days, right? If you're doing that internally, that's what you're going to do to protect your AWS account, because those are the only set of credentials you're using to access it. And the nice thing about it is if your employees leave, you delete them from your directory, you've effectively deleted their permissions from AWS. It's not like Joe left. Oh, he had an account in AWS too. We need to go and delete that. So you don't have any of that. You're managing it all within your own system. So we looked at a couple different options, and I've already discussed some of the differences. Let me be very specific about some of the considerations you should have when choosing the different session types. So these are things I would have you think about. First, what services do you want to use? The other consideration is how do you want to manage those permissions? Some people want to manage them within their enterprise. Other people want to have that separation where the permissions are managed inside of AWS. And then how are the permissions derived? Do I want to have a proxy server that has star access and I scope that down? Or I want to have a limited proxy server and I want to assume those. So those are some of the different things you want to be thinking about. Now, not all sessions, unfortunately, were created equal. And at some point, this chart will probably look all green, but right now it's important to know, as of today, some of the sessions you can use, for example, you can use a federated session with SimpleDB, but currently SimpleDB doesn't support assumeRole. So if you need that service, you don't want to be using roles for that. As I mentioned, we're continuously working with the service teams to make sure they support sessions. So that's one important consideration. The other thing, as I said, is where do you want to maintain it? So if you want to do it within your enterprise, you probably want to use a federated session. The consideration there is that proxy account is going to be fairly privileged, and you're going to want to be able to lock that down. In that case, you're going to be generating policies inside of your enterprise, and so you're going to take the burden of creating those and attaching that policy when you make the request. Conversely, if you want to do it within AWS, then you can use assumeRole sessions. The proxy server, in this case, really only needs the ability to assume role. In the sample I used, we also had to grant them list role. And then optionally, you can also specify a policy. So you could simplify the model where you assume one role, that role has kind of a god-like star access, and you can attach a policy. So you can actually do some of the same stuff with roles that you can do with federated sessions as well. So in summary, we looked at a couple of different types of scenarios. We looked at cross-account API access. This is where you can use one set of credentials. You don't have to go around sharing your long-term credentials with anybody. And you can go and you can revoke access to that role at any time. The other scenarios we looked at were API federation and single sign-on federation, right? In that case, you get to leverage the existing identity, continue to use the existing, say it's your Windows username and password that you use to log into your machine every day. And you get the benefit of enforcing those corporate policies, along with the fact that if anyone leaves, you simply delete them from one place, and you've effectively revoked their access to your corporation as well as the cloud. Some of the technology that we looked at, sessions are the heart of delegation. Hopefully, I said session and session over and over, so if you remember just a couple things, and you're like, oh man, what was Jeff talking about? Search for the security token service in session. That's going to get you to the right documentation that you're going to need to be able to build your applications. When you get a session, it's going to have a set of temporary credentials. Those are going to be in the form of keys and a token. You're going to use those elements to sign your API requests, and you're going to be able to make API calls and access resources using those. And then last but not least, understand the differences between them. Right? There are subtle differences in terms of the services that are supported across the session types. There's differences in terms of how those permissions are derived, and you want to make sure that you're using a scenario or using a session that supports the scenario and the use case that you're trying to do. So with that, I'll point you to some related content. First two sessions have already taken place, I should say the first two sessions are Jim's that was the hour before. If you missed that, you can go back to the recordings. I believe everything is going to be posted on YouTube. There's also an interesting scenario around mobile federation. Due to time, I couldn't really do justice to it, but the session MBL 302, it's actually unfortunately happening at the same time, does cover mobile federation, so that may be another session if you're interested in federation to go back and take a look at. And then tomorrow, Anders, who's on the same team as I am, he's going to be going through the top 10 IAM best practices. And so I really do encourage you all to attend that session tomorrow. If you have detailed questions, I'll stick around afterwards, but if we run out of time, we actually have a Meet the IAM team. It's today at 4:30. Slide didn't get the room on there. The room is 2502. 2502. So if you want to come, you want to talk to myself, some of the other members of the IAM and security teams will be there to answer your questions. Of course, you can follow us on Twitter. We're at AWS Identity. With that, I want to thank you all for coming out here. Your feedback is important, so please go out and fill the evaluation for this session and all the other sessions. And then, the last thing I'll do is I'll leave a slide up with some additional information and URLs where you can go find more information about IAM. All right, thank you very much for your time.